Good afternoon to one and all. Moving to the last session of fourth day, we'll have with an very uh, genius, and we can say him as a very practical person from NITTR Kolkata. So I heartily welcome Professor Dipankar Bose to our FDP. Dr. Bose is presently working as professor and the head of the Department of Mechanical Engineering in NITTR, Kolkata. Professor Bose has received his bachelor degree from Kolkata University and master degree from Jadavpur University. He has received his PhD degree from Jadavpur University. He has taught various subjects of mechanical engineering in his vast 33 years of teaching career. He has published around 60 papers in reputed international, national journals proceedings. He has guided several PhD and MTech theses. His research area uh, is fluid power, fluid mechanics, manufacturing technology, reliability engineering. He is one of the eminent personality in NITTR. Today, he delivered the talk on crossover process hybrid machining. I request Professor Bose to preside the session.
Thank you, Professor Dev, Professor Santosh Kumar Sahu. Okay, I am very much privileged that you have invited me. And nowadays, if you think about my area of specialization, actually field of work from fluid power to manufacturing, you know, it may appear a very, conflicting thing, but it is not like that. Nowadays, what happens, it is not the person who is the survival of the person who is the fittest, not. Main important thing is the adaptation. You got my point?
Sure.
So, what happened when I joined NITTR Kolkata from another central government organization? My specialization was fluid mechanics. But when I joined here, my head of the department then, 2003, he told me that I have to teach welding technology. And you can imagine where is fluid and what is welding technology. It is 180-degree apart. But I always consider difficulties as opportunities. And I took that opportunity, and you are invited within this span of these 17, 18 years. I have developed one of the best welding center in Eastern region. And I took the opportunity. You got my point? All type of welding machines are available. So that's why I'm telling you, you must be adapted. All my faculty members, those who are present here. Now, another important thing, earlier era was manufacturing economics, but now this area is information economics. So, machine learning, application of machine learning in non-traditional machining. This is the now hot topic. But what we are doing nowadays, still now, we are working on non-traditional machining like USM or ECM, all these things. Okay, got my point? But
Yeah.
this era is gone. Now this era is, material removal we are doing by removing material. That was our earlier manufacturing concept. But now manufacturing by addition. From where this concept come? Manufacturing, modern manufacturing by addition. Think about a simple tree. From a small seed, by adding of the cells, you are getting a big tree. This concept actually came into the mind of the technocrats to develop these additive manufacturing concepts. Okay. So that is the most important thing. Now, even in the field of why this crossover processes hybrid machining? Why? Because, nowadays, tremendous development has been taken place in the field of material science. Okay, so we are developing so many, superalloys. Okay, even composite materials and superalloys. Okay, machining of superalloys, we can take some non-traditional machining, but composite material, how it can be? Because it is a combination of metal and non-metal. Then hybrid concept came into picture, joining of 2 or 3 different types of non-traditional or traditional technology. We are getting the newer kind of machines. I am predicting within 2 to 3 years, your laboratory, you must procure or develop, this type of hybrid machines. Otherwise, very difficult to cope up with the. Actually, our teaching is some faulty system we are having. That is, we are teaching process-based teaching. We are not teaching product-based teaching. Am I right? Suppose this is the pen. Okay. Now, production of this pen, you require 10 stages. So, whatever you are observing, the 10th stage. But what was 9th stage? What was 8th stage? What was 7th stage? 6th, 5th, 4th, 3rd, 2nd, and 1. Why it is required? It is a concept of reverse engineering. Why it is required? Because if a student can find out in backward the manufacturing process of this pen, you can reduce the process and optimize the process. You can. Very important thing is the cost cutting. Now, even in the design, one new term has come. It is called frugal engineering. What is that? Frugal means what? Cost cutting. Okay. For example, your mobile phone. Now, the 40,000 rupees one mobile phone. What is the specialty in the mobile phone? You may have 125 apps, but practically, we are using only 20 apps. Now, if this is reduced to 20 apps, the cost of that mobile phone will be reduced to half. You got my point? So, all over the world, now this frugal engineering is coming into picture. You got my point? So, hybrid machining. Why? Because very difficult to machine items, components, very difficult, that we are using this hybrid machining. So I think I can start because the time is 1.5 hours. I feel it is a very short. I am a very talkative person. Don't worry, my dear friends. I will talk so many things of my experiences in teaching. Now, one important thing before my teaching, my dear friends, how you are taking the feedback of your students, of your teaching. In the class, you are asking some questions, concept clearance questions to the students. If they can answer, yes, they have understood the thing. But NITTR, it is a National Institute of Technical Teachers Training and Research Institute. Here, we are the person, we are giving idea to the technical teachers like you that how to update your teaching process. A beautiful system is there. Suppose today I am teaching hybrid machining, electrochemical machining. So with ultrasonic machining. Fine. Now before starting the class, I will give the students some 10 to 15 questions on that hybrid machining. Naturally, the students' performance will be very bad because they don't know the thing. Fine. Now, after delivery of the lecture, again you distribute those 15 MCQ questions to the students. If 80% questions are answered by them, your teaching is okay. That is the pre-test and post-test of teaching. You got my point? This is a very wonderful method and I apply here. Okay, when I am giving lecture to my MTech students or my technical teachers, So this is a really very challenging time. And after the delivery of the lecture, I am finding that they are answering most of the questions. Then it gives me a very wonderful, satisfaction that they have understood my teaching. You got my point? In teaching, all are teachers. Most important thing is that what? When you are giving lecture, it has been observed the retention power, only 2%. When you are giving the lecture to the students, 2 to 3% maximum. But when the students are listening and writing, 10 to 15%. But maximum retention occurs when you teach somebody, 70% retention takes place. Am I right? When you are teaching some topic, your conception must be very clear. Otherwise, you cannot teach. You got my point? So, teach always to somebody so that, your main knowledge level will be upgraded and uplifted. Now, okay, my dear friend, let me start with this. Is it visible?
Yes, sir.
So, my dear friend, this is the thing. Product of hybrid machining. Okay. Why it is required? Okay. Because higher machining productivity as well as accuracy and surface quality. Now, one important thing I am telling you. Now, initially when this non-traditional machining came into picture, our job was somehow easier. Only machining the item or the product, and we used to give some, optimization techniques and others. But nowadays, most important thing, accuracy and product quality. Now, supposing EDM machine, okay, in wire EDM, when you are performing a job, the quality of the surface finish is not so much. So how to improve this? Practically what I did, we have introduced in the dielectric some of the fluids, powders, okay, particular type of powders. So the quality of the surface finish became, high quality surface finish we have got. But my dear friend, the demand is more. Okay. Tougher material, harder material, stronger material, all these very difficult to cut. So I am telling you one important thing, the lathe, milling, shaper, these are the all conventional machines. Okay. Only mild steel. This era is gone almost. You got my point? Most important thing, even I am telling you in the welding operations, most of the colleges, the welding machine, what the colleges they are having, these are actually based on transformer based. Okay, transformer based machine. But nowadays, most of the welding machines are developed into inverter based. Okay, to reduce the power consumption. Okay. Now, what happens? This inverter, now students, what they are learning from your college, they are working on transformer based machine, but when they are going to industry, all machines are converted into inverter machine. So there is a lot of gaps are there. Okay. Now, my dear friend, most important thing, I want to tell you some of the hard materials, okay, difficult to machine materials, hard materials, nickel alloys, titanium, ceramics, ferrous alloys, cobalt chromium alloys. ductile materials like low carbon steel, magnesium alloy, copper alloys, non-homogeneous material, composites, metal matrix, synthetics. So all these things are actually now the new material, new materials have come up. Now another important thing has come into picture. What is that? One important thing has come nowadays, another technology has come. What is that technology? Nanotechnology. Why nanotechnology is so popular? Can you tell me? Why nanotechnology is so popular? Hello, my dear friends. Have you heard about nanotechnology? Am I audible to you?
Yes, sir.
Yes, sir.
So, have you heard about nanotechnology?
Yes, sir.
What is meant by nano? The size is 10 to the power minus 9 meter. But why it is so important? You got my point? Because the property of the material changes when it is sized to nanosize. For example, I am giving you one important example. Suppose your graphites are your pencil leads, okay, and these are the most brittle material. But when these graphites are sized to nanosize, it becomes the world's most hardest material, that is called carbon nanotube. You got my point? So the property of graphite has changed when it is sized to nanosize. This technology is coming into now all over the world. It is coming. Okay. But most important thing is that there are some nanofluidic channels. They are doing a lot of havoc in the manufacturing world. Now it has been observed that, I think you have heard about Intel. The owner of Intel, Gordon Moore, he has said the size, in a PCB or in a printed circuit board, you can suppose add 100 type of resistance or whatever may be the components in a space in the PCB. After 18 months, it becomes 10 times. It can accommodate. But the problem, what is the problem? When this so much components are clubbed together, heat dissipation, tremendous amount of heat is dissipated. Now to remove this problem, what they are doing? They have introduced nanofluidic channel. You got my point? Nano channels, what happened? Nanofluidic channel does not obey Ohm's law. So naturally there won't be any heat generations, can be easily compensated by the nanofluidic channel. Another important thing, I think all of you have smart material. What is that? Can anybody tell me? Smart material? Because manufacturing world advancement.
Good afternoon, sir.
Yes.
Smart materials means they can change their shape after we can use some machining process. They can shape their shapes by their own.
Okay.
That means
Yeah.
nowadays you can see, sir, recently one material is developed, that is self-healing material. Recently.
Yes.
Memory, sir.
There are memory materials.
Yes, sir. Yes, sir.
Another material is there. Actually, smart materials are non-metals, but they can conduct electricity. So, main intention for the technocrats or scientists was that use of metal should be minimum. So, they have developed this component, which is an organic type of component, but it can conduct electricity. So, you think about your mobile phone nowadays. How much percentage is metal? Very less. You think about your new car. How much percentage is metal? Very less. Okay, in comparison to others. Now, my dear friend, coming back to my lecture, Now suppose titanium. It is a very widely used, okay, material in the aerospace. You know, my dear friend, two branches of engineering apart from computer science, okay, or IT and whatever may be, two branches of engineering will very much will be in demand in coming area. One is aerospace engineering, another is automobile engineering, hybrid vehicles and others. In aerospace material, actually, titanium is widely used and also medical industries. It has got some exceptional properties, but it is a very notorious material. Okay, very difficult to machine this material. Okay, so many tales of broken tools, ruined work pieces are the abundant. Okay, so titanium is a one type of culprit material. Now, another important thing is Inconel machining. Okay, you know it is a trademarked word of Special Metal Corporation. Okay, it is a high nickel superalloys. Okay, and it is actually resilient to corrosion and oxidation at higher temperature when it is used. Okay, but and also it is used in aerospace industry, but it is very difficult to machine. Okay, because it does not get any softer when the temperature rises. At the same time, you may think about cold working, but cold working increases its hardness and making it difficult to machine. Okay, but when Inconel is machined, its hardness increases non-linearly and wearing the tool disproportionately. So this is another difficult to machine material. Another important thing is cover. Cover is also a special nickel cobalt ferrous alloy. Okay, and because it is designed to have the same thermal coefficient of expansion as glass. Okay, and it is known as control expansion alloy. Okay, and it was developed initially for sealing electronic components like vacuum tubes, CRTs, and light bulbs. Okay, but normal metals don't work for this purpose because they expand and contract quite ready with changes in temperature and breaking the seal. So, but like most nickel alloys, cobalt also exhibits work hardening when machining, slowing the machining process and even wrapping the work. Now another important thing, Invar. Okay, it is a nickel ferrous alloy. This is also extremely low thermal expansion. Okay, it differs from copper in that it is a control expansion metal. Okay, same coefficient of thermal expansion as borosilicate glass, whereas Invar is an extremely low coefficient of thermal expansion metal. Got my point? And it is used to make extreme precision equipment like scientific laboratory equipment, gauges, clocks, stencils, like that. Okay, but another important thing is that Invar does not get hardened with temperature, but only with cold working. So the hardness increases during machining is relatively lower, but it does not make the material much easier to machine. So I am telling you some of the material. So there are plenty of materials have been developed, but more attention so directed towards machining processes where the mechanical properties of the workpiece are not imposing any limits on the material removal process. Okay, so unconventional machining techniques came into practice. Okay, right? But this is not so much as per the requirement. Okay, so unconventional machining, I don't want to say so many things because everything: mechanical type, water jet machining, abrasive jet machining, ultrasonic machining, electrical energy utilization, ECM, thermal means EDM, EBM, LBM, chemical, ECM, chemical machining, all these things will come into picture. Now, why hybrid machining? Now I am coming to the picture. Okay. Combinedly, mutually enhance advances and avoided the adverse effects of the constituent processes produced when they are individually applied. Very nice. Okay. There are wonderful words is there in the definition. But why it is required? Because why it is called hybrid? Because it will be more clearer to you. Here you see. Conventional process, okay, unconventional process. When they are bridged, you are getting a improved process. Or unconventional process to when they are, bridged, you are getting an improved process. Now, my dear friend, now this is the, new era of manufacturing. Okay. Now, what are the advantages? Machinability, MRR is high, surface finish, accuracy. Long back when I worked with die sinking type EDM machine, it used to take 5 hours, 6 hours to make the impressions. Okay. But we don't have this much of time. And also, we have to make the MRR more MRR. Okay. And at the same time, surface finish should be very accurate. Okay. So, these hybrid machines will give you that requirement. But there are some adverse effects are also there. Sometimes bars are there. Hedge is maximum. Sometimes residual stress will be there, inherent stress inside the structure, all these things. But if you consider the advantages is more than the adverse effects. Now, there are two categories of hybrid machining process, where the processes are directly involved, okay, in the material removal. Another type of hybrid machine is there. One will be the most principal machine. Others are actually give some, assistance to have some better MRR and surface finish. Always remember, most important thing, why this hybrid machine? To get MRR, main intention is that better MRR as well as quality of the product. Okay, now my dear friend, first, hybrid machining is, I think you have heard, all of you, abrasive water jet machine. And it is not a very old one. In 1979, Dr. Muhammad Hassis, working at Flow Research in USA, he started researching methods to increase the cutting power of the water jet so it could cut metals and other hard materials. So, Dr. Hassis is known as the father of the abrasive jet, water jet, and invented the process of adding abrasives to the plain water jet. Okay, so he used, garnet abrasives. It is just used in the sandpapers. Okay. Water jet containing abrasive could cut virtually any material. In 1980, means how many years? 40 years back. Okay, abrasive water jets were used for the first time to cut steel, glass, and concrete. And 1983, the world's first commercial abrasive water jet cutting system was sold for cutting automated glass. Okay, when the development is taking place for automobile engineering, now at the same time, there are some sister organizations which will be used to process the automotive parts, how to cut and how to machine it. then this abrasive water jet machining is there. You know, there is a saying in the industry that in the workshop, if you don't have a water jet machining setup, it is just like a, carpentry shop without a hammer. Okay, so this is the saying. Okay. Now here you see high pressure. A main important thing is the nozzle. Here abrasive and air inlet through this high pressure water inlet. So ultimately the mixing takes place. And if you see here, the mixing will take place like this. Okay. Interaction with focusing tube. This is actually made of a very difficult material, sapphire. Okay. Sapphire. Okay. So mixing chambers are there. So you can find out the velocity and others. So this is the way you can make the nozzle of this abrasive water jet particle. Now, my dear friend, please see how many intrinsic parts have been developed by this abrasive water jet. Huh? Can it be possible? Can it be possible by our conventional machining?
No, sir.
These are the things actually. Okay, but you can actually, all are very capable engineers here, those who are listening. You can develop this type of setup. Okay, it is only, your intention is required. Otherwise, innovate. The owner of Facebook, Mark Zuckerberg, what he has said about Indians, or his partner, I forgot who told this, but statement is that Indians are very good in studies, fine. They are getting good jobs, they are purchasing Mercedes, but where is the innovation? You got my point? Am I right? Whenever faculty members are coming to my place for training and other, I ask them, how old your college is? Fine, 20 years, 30 years, 10 years, somebody is 80 years. But when I ask, have you developed any product which is, required for your surroundings and others, for the mankind and others? The answer is a big G. It is not their fault or our fault. Our system, our education system is like this only. Okay. So this is the case. Okay. So now I am telling you, when we are developing some setup, we have to make sure that what are the purpose. Okay. Now, my dear friend, you see this abrasive water jet machining. Now what happens? You see the dragon. How intrinsic cutting is this? But how it is done? Okay, from a bulletproof glass, it is by abrasive water jet. This has been done. Okay. Now, another hybrid machining is there. It is called laser hybrid welding. Do you have any idea? It is a combination of laser light and electrical arc. Okay. Now, in welding, most important thing is that MIG welding is the most versatile one. Why? Because, MIG, when the MIG welding is going on, there is no stoppage of continuous, welding rods you are getting. It is a automated system. So, MIG welding and laser welding, both are combined. Okay, but difficult for TIG welding, because TIG welding you need to keep the stick and your torch very minutely. TIG welding is an artist welding, you got my point. But MIG welding is utilized for hybridization. And with the laser and MIG, if you visit most of the automobile industries, the joining of different parts of that car, you know what happens? It is done through hybrid machining. You got my point? So, laser hybrid welding. Okay. TIG, there are TIG, plasma, MIG. In my workshop, I have got plasma cutting, plasma arc welding, pulse stick, so many things I have arranged within a very short period of time. And if you come, you are all welcome. And my my mail address is there. Okay, if you require my mobile number, I can give. If you come to Calcutta, you can visit the workshop. Okay, now I am coming to that. So many things, I will send you the lecture notes so you can go through that. I want to discuss the thing here only. See, my dear friend, what is mag welding? What is mag welding? Because mag welding is what happens? It is a MIG welding where CO2 is the gas. So we are telling it is a mag welding. And when ND and laser are combined, you see the quality of the weld. It is a hybrid laser mag welding. You see the quality. Okay. So it is a very, very interesting. You know, what is the job here, MIG welding or mag welding? Deposition. But what is the job of laser beam? Penetration. If you get the deeper penetration, quite obviously MIG welding will give the joining more deeper way. So the welding will become more, strength, everything will become more better. Another important thing is that this is a very versatile welding, MIG and laser hybrid welding. Okay. Any question? Any question? And here you see, it is a joining of carbon manganese steel. You got my point? Okay. So this is a very unique type of, and everywhere, you go to Telco, you go to Ashok Leyland, you go to Maruti manufacturing unit, everywhere the common is that they are using laser hybrid machines. Okay. Now, first of all, let us think about hybrid electrochemical processes. Okay. ECM, Faraday's law. In our school level, we have learned about this electroplating. Electroplating is deposition of material. But in ECM, electrochemical machining, it is the reverse. It is the reduction of material. Okay. The mechanism is known as chemical dissolution or electrochemical dissolution. Okay. Now, when this machining process, if you can enhance by using mechanical machining action or thermal assistance. Okay. And ultimately what happens? Ultimately what is the requirement? Higher MRR and improved surface quality. So that is if you think about the thermally assisted processes, you can use laser beam. Okay, which the heating of the inter-electrode gap enhances the dissolution process in laser assisted chemical etching. It is known as, or it is known as LAE, or laser assisted electrochemical machining. Okay, during which one most important thing, always you remember when you are doing some machining operation, current density, current per unit area. The main intention to rise that current intensity, and the dissolution phase becomes more intensive, leading to a more productive machining process. Or as you know, why this hybrid machining is coming into picture? That is machining of difficult, metals, but most important thing to increase the MRR as well as the surface finish. So there is a term called mechanical abrasion. It is combined with ECM and lot of hybrid processes, electrochemical grinding, okay, electrochemical honing, and electrochemical super finishing. All these things, these are all hybrid process, right? So another important thing, when ultrasonic or US made or ultrasonic assisted electrochemical machining, which employs ultrasonic machining component with ECD to improve electrolyte flushing and hence the material removal rate. Again, the demand is to increase the MRR. Another important thing, the mechanical action of the fluid jet, okay, which can enhance the chemical dissolution during electrochemical buffing, that is finishing, ECB. Okay, now my dear friend, you think about this. You see, this is the, you can say pictorial line diagrams, how these things are, hybridization takes place, and suppose, this is your ECM or ECD, electrochemical dissolution. When it is combined with fluid jet, the process is known as ECB or electrochemical blocking. Now, when ultrasonic and ECD are combined, you are getting a new process, US made. When ECD combines with laser beam, you are getting ECMF. When ECD combined with mechanical action, you are getting electrochemical grinding, electrochemical honing, electrochemical super finishing. Okay, so you see, for how many new techniques has been developed. Okay, and in India, IIT Kanpur, okay, Roorkee, as well as Jadavpur University Production Department, they are developing some of this type of hybrid machines. Okay, now it is your turn. You can develop this type of hybrid machines. Actually, what is the main target? Higher MRR and surface quality. For that, you can develop anything. Any question? Am I clear to you? Hello?
Yes, sir.
Are you getting interest on this? I think,
Yes, sir. Yes, sir.
okay, thank you. Now, another important thing is that electrochemical grinding. Grinding we know, but in ECG, it utilizes a negatively charged abrasive grinding wheel and electrolyte solution and a positively charged workpiece. Okay, the process is similar to ECM, but the cathode is a specially constructed grinding wheel instead of a cathodic shape tool like your conventional ECM. And there are some insulating abrasive materials. It may be diamond or aluminum oxide of the grinding wheel is set in a conductive bonding material. Now, my dear friend, you can think about that. In ECG, the non-conductive abrasive particles act as a spacer between the wheel, conductive bonds and the anodic workpiece. Now there are some always inter-electrode gap that is very much important. It is 0.025 millimeter or less, and it is servo control. Okay, servo control distance is maintained, constant distance is maintained. Okay, now here you see, my dear friend, this is a very interesting one. Your conventional grinding machine, but when it is coupled with ECM principle, it becomes a surface ECG. You got my point? So a newer, true technology, ECM as well as the conventional mechanical abrasion like grinding, you are combining, you are getting a one hybrid system. Okay. Electrolyte is generally sodium nitrite is provided to ECD, and wheel abrasive particles grid size are there 62 320. Okay, and there are so many research items are there. If you can develop a machine, you can find out the optimum abrasive particle size, grid size. That is also one research. Okay. Now another important thing: the wheel is rotating at a surface speed of 20 to 35 meter per second, and current rating is 50 to 300 ampere. Now, when a gap voltage of 4 to 40 volt is applied between the cathodic grinding hole and the anodic workpiece, a current density is about 120 to 240 ampere per centimeter square is created. Really, this is a very wonderful development, this current density. Okay, and not only that, current density generally depends on the material being machined, gap width, and the applied voltage. Now, material removed by ECG, okay, actually, always remember in ECG, the main portion of the material is removed by ECG only. And mechanical action, abrasive grid, only 5 to 10% of the total material removal. So here you see, this is the total component. Now here what happens, this is your work table, insulations is there, this is your workpiece, this is the grinding wheels. Okay, with this, the grids are there, and these abrasive particles are fed through this electrolyte, and the machining takes place. So it is a very, very, very popular nowadays ECG machining systems. Okay. Can you develop? Hello, my dear friend. Can you develop this type of machine? Huh?
Yes, sir. Yes, sir.
You try this. I am telling you, all are innovative mind is required nowadays. And you will get this innovation from students also. Only you guide them, you will get the havoc. Okay. Now, one important thing is that removal rate by ECG is 4 times faster than any conventional grinding. And always, it produces always bar-free parts, and that are unstressed. And the volumetric removal rate is typically 1600 millimeter cube per minute. So ECG is a hybrid machining process that combines mechanical abrasion and ECG. Okay, so this is the beginning. Earlier I have told you what? Initially I have told you what? First is abrasive water jet, then laser hybrid. Now it is a ECG, electrochemical grinding operation. Okay. Now here you see, my dear friend, the flowchart. Ultimate product is ECG. So here ECM plus mechanical grinding. So ECG phase and mechanical abrasion phase, ECG phase ions, and for mechanical phase, abrasives, and as abrasive tool, this is a cathode and workpiece, ionization takes place. But what is the actually main plus point? By combining both ECM and MG, mechanical grinding, you will get a better removal rate. Okay. Now, why? This is very popular. Okay. The machining parts made from difficult to cut materials such as sintered carbides, creep resisting inconel, limonic alloys, titanium alloys, and metallic composites. Okay. So, generally, you can produce tungsten carbide cutting tools, fragile parts, and thin walled tubes by this ECG. What are the advantages? Advantages are too many. No work hardening, no barring, distortion of thin, fragile or thermosensitive part, no distortion. And surface quality is very good. And even it can produce very narrow tolerances and longer grinding wheel life. Okay. Disadvantage is there because capital cost is high, and it is another limitation is there that it is actually limited to electrically conductive material and corrosive nature of the electrolyte. Okay. And always, disposal and filtering of, electrode is necessary. Now, my dear friend, another technique. What is ultrasonic machining? Can anybody tell me? If I tell you, make a small square hole of your, of a glass. Okay, if you want to make a square hole, what non-traditional machining technique you will take? It is a brittle material. So generally we are taking ultrasonic machining concept. Now, when ECM is coupled with ultrasonic non-traditional machining, then it becomes another hybrid system. Okay. So, but it is sometimes, it can very much effective. ECM is only effective for machining conductive materials, and ultrasonic machining is suitable for hard and brittle material like, ceramics. Okay. So, it is not so much effective when you are using composite material machining. Okay. So, merging these two processes, okay, when you are machining with the difficult to machine composite material. So, ultrasonic assisted electrochemical machining, or it is known as USMAC, combines both ECM by to remove the metallic conductive part, and ultrasonic machining for removing the non-conductive hard and brittle phases. So that's why this ultrasonic system and ECM are coupled. Now, my dear friend, you see this. Generally, here you see ultrasonic, it is known to us. A transducer is there. It is called horn. The tool is vibrated, but at the same time, electrolyte plus abrasives, when they are fed into that, this is nothing but in a combination of ECM as well as, ultrasonic machining. That's why it is called USMAC. Okay. Generally, voltage of 3 to 15 volt DC is normally used, and current density is between 5 to 30 ampere per centimeter square. Okay. So this is another hybrid. I'm telling you, within this shorter period of this 1.5 hours, okay, very difficult to discuss a particular research area. So I'm trying to give you the area where your eyes will be open. I think some of you may already know, but this is the actual product. Those who are manufacturing, dealing with the manufacturing technology, these are the actually main, technological development in, in non-traditional machining. I am telling you, my dear friend, nowadays, non-traditional machining has become a traditional machining nowadays because materials you are developing. But now these hybrid machining setups, these are become now real non-traditional machining setup. Am I right? Huh? Am I right?
Yes, sir.
Yes, sir. Yes,
Yes,
sir.
sir.
So now here you see US made. What is that? It is a combination of ECM plus USM. Then electrochemical dissolution phase, ultrasonic machining phase, ions, abrasive tool, ultimately electrolyte plus abrasives, you are getting the, work done. Recently, I have purchased one ECM, macro ECM system. Okay, effective. It can work with, Inconel material and others. Okay. But combining ECM with other systems that we couldn't do because the machine is very costly, 20-25 lakhs. Okay. So afterwards I will see to that what development we can have. Okay. So this ECM actually it is carried out, temperature between 20 to 80 degrees centigrade. So but when you are doing machining with ECM, only dissolution action occurs in the machine surface. So it is possible to increase the rate of ECM by increasing the temperature of the inter-electrode gap. Okay. In this regard, if you can provide laser beam, okay, so naturally increasing the temperature of the machining zone during laser assisted ECM, or it is called ECML. Here you see ECM, ECD phase, laser beam, then machining takes place. So this is a combination of the flowchart when ECM is combined with this laser beams. So this is another hybrid machine. Now hybrid thermal processes. Thermal process means, can you give one example? Thermal non-traditional machining setup. Okay. Any thermal machining can be assisted with electrochemical dissolution and mechanical abrasions. Okay. Higher MRR and improved product quality. But hybrid thermal processes, if you come into picture, electro-discharge machining, EDM, now there is a term called electro-discharge grinding and abrasive electro-discharge machining. It is known as AEDM. Okay, so it is employing solid or loose abrasives in dielectric liquid. So again, when electro-discharge machining with ultrasonic another combination is made, it is known as EDMUS. Okay, or EDMUS, popularly known as, introduces ultrasonic vibration to the tool that enhances the electro-discharge action. Okay, but at the time the cavitation is very desirable. Cavitation generated by this vibration enhances the EDM by improving the dielectric flushing. So MRR will become from the surface craters during macro drilling and production of slots and grooves. So there is a triplex hybrid machining adds to the material removal from EDE phase to the ECD phase and mechanical action. So it is called electrochemical discharge grinding. Now, my dear friend, you see this. One is EDE method, electrodischarge, then electrochemical discharge, mechanical action. Now, when EDA, electrodischarge with mechanical action are combined, we are getting electrodischarge grinding or abrasive EDM. But when ultrasonic is coupled with EDE, we are getting NMAS. When this electrochemical ECD dissolution is combined with electrodischarge evolution, we are getting ECDM or EEDM. So, my dear friend, so many combinations you can make and you can develop a newer product. Okay. Now let us think about now what grinding, electrochemical grinding. Okay, but a new system has come. It is known as electrodischarge grinding. By taking the principle of EDM as well as the combining with the grinding, okay, we can make your required MRR and others, everything can be increased. Okay, so now here these are the some parameters you can go through it. When I will say the lecture notes, I want to tell you the higher machining current. Now here you see, this is the electrodischarge grinding. Remember, earlier I have discussed, we have known to this point electrochemical grinding. Now electrodischarge grinding. Okay, same thing, same process, non-abrasive metallic wheel and dielectric fluid. Now the sparks are generated and this is the workpiece. So electrodischarge, electric discharge, cathode and anode, we are sending it. In this case also, maximum material removal takes place in electrodischarge method. Only 10 to 15% will be generated to the mechanical action. Okay. Now EDG, electrodischarge grinding. What is that? EDA phase, then plasma, metallic wheel, ultimately the material removal takes place. This flowchart is really very useful to understand the process. Now, my dear friend, another technology. Are you getting interest in this, what I am telling to you?
Yes,
Okay,
sir.
you can ask so many things to me. Okay, if I can answer, I can answer you. But nowadays, my dear friend, who is your best friend? Huh? My best friend is nowadays Google. Okay, whatever you want to know, you will get some at that particular instance the information. YouTube, excellent methodology. Now, in the teaching methodology, do you know what is blending method? Blending teaching method? Do you know? Anybody? Blended type teaching methodology? Anybody? What is blended type? I am giving you one example. Actually, it has been one important thing. Everybody is telling bad things about Corona, but I am telling you the positive thing of Corona is that we have adopted very fast use of virtual, virtual mode teaching. Is it not? Otherwise, if it was required, it would have been taken another 2 to 3 years to learn all these things. But now, according for the necessity, we are doing the thing. Blending type teaching is that, suppose a hybrid machining, the lecture I am giving to you, suppose you have to give to your students. You record your lecture, okay, and send this recorded lecture to the students, social media, Facebook or, WhatsApp, whatever may be. Let them go through your lecture. Then, when you are going to the class, the discussion on that topic will be done with the students. That is called blended type teaching methodology. I am practicing sometimes, with my master degree student. I am recording one lecture and I am sending it to them, and they are responding very nicely. What is your idea about this? Blended type of teaching?
Sir, it is a nice one.
Yes.
And I think it is more effective for student to understand the things and clear their doubt within a short span.
Yes. So my request to you, okay, Devji, and you can start this. You can start this technique. Okay.
Yes, sir.
That will be very useful, and it is very useful method nowadays. Now another important thing. Now I'm coming back to our business. That is the abrasive electrodischarge machining. It is simply known as AEDM. It is a hybrid process based on EDM, where free abrasive grains such as silicon carbide powder are added to the dielectric fluid. And in addition to the major EDF thermal phase, mechanical abrasion assistance is added. So the energy which is carried out by the plasma channel in case of EDF phase, also by abrasive grains for mechanical action. Okay. So the machining media consists of dielectric and solid particles. Fine. But mixing silicon powder into the dielectric reduces the electrical capacitance across the discharge gap by increasing the gap size. So as a result, what happens? Better dispersion of spark, improvement in the discharge characteristics, especially in the machining of a large workpiece. So this is a very, I am telling you, all these type of hybrid system were developed as per the, necessity. You got my point? Necessity is the mother of invention, we know. So these are the things actually have been developed according to the necessity. Now, with your, wisdom and other, you can develop more, hybrid systems. Okay. Now, my dear friend, you see this. Here, here the tool, feeding, vibration, orbital motion, everything, takes place. At the same time, abrasives are fed to the workpiece. Okay. But at the same time, this DC power source is there. Okay. DC power source is there. Now here you see AEDM. It is nothing but abrasion plus EDM. So what we are getting, mechanical abrasion phase, EDE phase, abrasives, plasma are generated. Ultimately the material dielectric plus abrasive, ultimately the material removal takes place. Now, AEDM, what is the plus point? The finishing, you will get just simply a mirror-like finish. Okay. Okay. Which is uniform and free from cracks. Now, this AEDM is widely used to produce dyes without need to remove the heat affected layer using mechanical polishing. Okay, and it is used, AEDM, it is used to produce plastic molding dyes. AEDM is very much utilized. Okay. surface characteristics of tool steel. Okay. Now sometimes fine tungsten carbide powders are added to the dielectric, which adds alloying elements and hence enhances the hardness and corrosion resistance of tools and dies. So this is a really a special kind of invention, my dear friend. And also, it also, improve their tribological features and changes the surface roughness. Now, at the same time, powders such as silicon and tungsten have been used to harden and increase the corrosion resistance of steel workpieces. Okay. All the, when we are facing these problems of these corrosions and others, all these things, so many things are developed but we have found that hybrid machining is better approach. Okay. But nowadays, EDM with ultrasonic assistance. When the need for machining hard and brittle material is very steadily increasing. Okay. Several problems traditional machining for this tool life and surface cracks. So EDM can be applied to conductive hard and brittle material when electrical resistivity below 100 ohm centimeter. But what is the major drawback? Low efficiency of sparking and formation of OC open circuit, arc and short circuit pulses, which are non-productive with respect to the material removal rate. But on the other hand, ultrasonic machining can tackle hard and brittle material, okay, which have difficulty withstanding the cutting forces during conventional machining. Okay, now at low machining rates, parts have a good surface finish can be produced using USM. But now when the interaction between EDM and ultrasonic vibrations in the machining process, or it is not known as EDMS, has a greater productivity than the sum of the productivity of individual EDM and USM at the same machining condition. Okay, that's why this process is adapted for rapid production of graphite electrodes for EDM, where cutting, drilling, and engraving can be done easily. Okay. Now, it is actually similar to that used in USM with the dielectric or deionized water, replacing the abrasive slurry as the machining medium. Now the ultrasonic vibration of the tool or workpiece together with the low-cost DC power supply generates the discharges across the machining gap. Now the MRR, EDM with ultrasonic assistance, I am telling you, the MRR employs the electrodischarge phase for melting and evaporation of the workpiece material. That we know. By the plasma channel, it is similar way to normal EDM. But the intensity of the discharging action actually depends on the working conditions such as the gap voltage, amplitude, frequency of ultrasonic vibration, as well as gap flushing condition. Now, my dear friend, ADMAS is like this: ultrasonic, okay, with EDM. Ultrasonic with EDM. It is a newer kind of material, setup has been developed. Okay. It is popularly known as ADMAS. So actually, because of ultrasonic vibration of the tool, its front surface moves down towards the workpiece surface and the electric field intensity increases. But this electric field causes the metal debris in the machining media to be suspended and form a bridge across the gap. So my dear friend, EDM, EDE phase, then plasma, ultrasonic vibration, dielectric, the material removal takes place. Now, electrochemical discharge grinding. This is also another methodology, my dear friend. It is known as ECDG. It is combined with electrodischarge erosion, ECD, and the mechanical action. Here in this ECDG, the grinding wheel is connected to the negative terminal while the workpiece is connected to the positive polarity of pulse power supply. And electrolyte is flowing into the inter-electrode gap. Okay. And this rotating wheel is set at a depth of cut while the workpiece is fed at a constant rate. And in this case, surplus material is removed from the workpiece surface by the anodic dissolution of the ECD phase. And the mechanical action is also there, abrasives or diamond grains, and the erosion phase due to the spark discharge. Now, my dear friend, you see this. This is the electrochemical ECD discharges. Electrolyte is supplied. Here, this is a conductive abrasive wheel. At the same time, ED supplies, this discharges electric spark. So, ultimately, it is called ECDG schematic diagram. Okay. So, here you see, my dear friend, what is that? How many things are there? Huh?
3 things.
ECM, grinding, EDM. Okay. Ultimately, ECD phase, mechanical action phase, EDE phase, ions, abrasive, plasma, and abrasive tools, ultimately material removal takes place. So, it is a really very, actually I have told you so already, these hybrid machines were developed as per the requirement. Okay. It is not the inherent machines. It is a combination of 2 or 3 actions to ultimately, those who are in the manufacturing world, you always remember what is your main important intention. Your main intention is that higher MRR and better surface finish quality. To achieve this, all the flaws of conventional, non-traditional machining. Why I am telling conventional? Because these things have become now, EDM, ECM has become very conventional type. They have got some inherent difficulties. That is removed by hybriding. Another important thing, my dear friend, tremendous development has been taken place in the field of metrology. What is our common concept of metrology? Can anybody tell me? Huh? In the class, what the students are learning in the workshop? What is the measuring instruments in the workshops? What are the measuring instruments in the workshop?
The steel rule, vernier.
Nowadays, my dear friend, everything is obsolete. Okay. Now metrology is called vision-based metrology. You go to shopping mall. What happens? They are scanning. Through scanning, you are getting the reading. Same thing. In vision-based, you can note it down, the term vision-based metrology. in all industry, the all industry, they have adopted this vision mesh metrology. Only thermal, the optical scanning is there to get the very difficult, because nowadays the shape of the components are so difficult, very difficult to measure with your conventional measuring setup. So only the optical scanning is done. Now we have got one thermal one camera recently we have procured where you can find out the dimensions to the camera. Okay. So you have to move with the modern systems. That is very much required. So vision-based metrology is very much needed. Some idea. Optical metrology. Okay, in shopping mall, have you seen what the person is doing? Huh? Just simply with the barcode and they are scanning it. Same system is coming in the industry already. Now, industry 4. In this area, what is the main idea of industry 4? 24/7 and 100% quality. Okay. So, what happens in most of the industries nowadays, quality control division is not there. Why? Can anybody tell me? Why? Quality control division? Earlier it was there. When the productions units, they used to produce so many components, similar components, nut bolts and others, everything, and they used to check it in a gauges and others. Some parts are rejected, some parts are accepted. But nowadays, everything is accepted. Why Because all machines nowadays having inherent, checking system, or you can say feedback system. So whatever is coming out from the machine, there is no flaw. So why you require quality control? Are you getting my point? The concept is changing in the manufacturing world. So this is another example of, this process of electrochemical discharge grinding due to the application of pulse voltage in electrolytic solutions. The most common electrolytes are solutions of NaNO3, NaNO2, NaPO4 and KNO3. So many types of common electrolytes. Okay. Now it is customary to use ECDG electrolytes with surfactants, then corrosion inhibitors and complex forming agents. So my dear friend, here important thing. One laser assisted turning. Now turning operation we are doing by your conventional lathe. Okay. But by applying laser, you can make your turning or more accurate turning, you can do this operation. Now EDM. There is a laser beam is there. It is a pre-machining by laser ablation. Okay. You got a hole. Ultimately what happens, it is a pre-machining. Then post-machining by EDM, you can make the hole more accurate and surface quality will be better. So this is another, laser assisted EDM process. Okay. So anything you want to tell me, I can discuss with you. Some of the references I am giving you. Now, you can have this book specially, is a Iranian. This book is very good. Do you have, anybody has got this book? Huh? In the internet, you can get it. Through Google, you can find out. Okay. Now, my dear friend, any question? Any question? Difficult. In 1.5 hours, very difficult. Only, my sincere request to you, I have given some idea to you, okay? But now your job. Always, innovation. Innovation is the most important thing. Now this is an era of startups. Okay? Don't bother about jobs and others. Only idea matters. You got my point? Only idea matters. One boy from Mumbai, he was actually class 9 pass. He got directly admitted to Berkeley University from Mumbai. Why you know? The boy is having 156 patents. You got my point? So that's why because your great professors from IITs or Jadavpur, generally they are good researchers. So they will pinpoint of their lecture on a particular research area what they are doing. This is also very good what they are giving to you. But I wanted to give you the area where the total non-traditional, it has just, destroyed the concept of conventional non-traditional. I am telling you, it is a conventional non-traditional. Okay, this is also now has become bad. Now it is an area of hybrid machine. Like young people, when you are doing research on manufacturing, go for that. An ideal place I can tell you, IIT Kanpur, they are doing this thing, and also Roorkee is also doing so many things, and IIT Patna also they are doing some work on that, micro drilling and micro. So all these things is a combination of research, but unless you develop, and my request is that develop any simple hybrid machines, any simple hybrid machine. Okay. I always believe that all mechanical engineers are the designers. Inherent designer. You got my point? Inherent designer. Now, people are telling that production, there are so many tools. AutoCAD, CATIA, fine. You should know all these tools. Okay. But first, you have to determine the dimensions. From that to get the dimensions of that particular product, you have to become a good designer first. Okay, that concept should be, basic concept should be there. You got my point? Okay, any question? I am free to hear from you.
Okay, I think there is no question from participants, sir.
There is a plus. If there is no question, there is a plus point and there is a minus point also. Plus point
Sir.
is that, okay, they have absorbed it. Minus point is that they are not actually liking this lecture. That is the thing. Okay. Yes or no?
Good afternoon, sir. It's Nilanjan.
Yes.
Yes, sir. So we understand all your points because we have
Nilanjan.
learned it from you.
Okay. I think, thank you very much. Okay. So thank you very much, all of you. Okay. And again,
Okay, sir.
thank you, Professor Chittaranjan and Santosh Kumar Sahu. I had a very, good interaction.
I request Sir Santosh Kumar Sahu to propose vote of thanks to Dipankar Bose, sir.
Okay.
Thank you, sir, for sharing your expertise in very recent technology like hybrid machining. So especially we have learned so many things in 1.5 hour from beginning for model machining process practice to how about nano, then titanium machining, then cover. And also you have know about your Invar. And also you have to learn why hybrid machining is required for us, like AWSM, then laser hybrid welding, and then electrochemical grinding, then laser assisted ECM, then hybrid thermal process, then electrolysis grinding. All are things, the new innovation things. Then we little bit try for doing work on that, and I think which is a very interesting, and I hope all our participants acquire knowledge about the different technique and new innovation in the field of hybrid machining. Thank you, sir.
Thank you, thank you.
Sir, specially, sir, I want to thank you for giving idea to implement that blending teaching methods.
Yes, yes, that actually all of you, you know, it is very
That not
nice.
only improve our knowledge, but also that not only improve the knowledge of the student, but also we are being forced by the teachers are being forced by the student to acquire more and more knowledge and
Yes.
get the things in a right way.
Please practice this. You will enjoy it. You know, and students will also like that.
Sir.
Because nowadays this concept is gone. Traditional class hour and other. You can change your timing. You send your lecture to the students. Okay, recorded answer. Let them listen. Let them understand. Okay. Also give some YouTube links for that particular lecture. Then they will be very much benefited, and you ask questions. You send some, Google Meet questions based on that.
Sir.
So this is a new technology, very easier technology. Okay.
Sir, thank you once again for sparing valuable
No, thank
time
you very much.
delivering.
And I will send the lecture notes, PPT just now.
Yes, sir. Yes, sir.
Okay. So thank you. Namaskar to all.
Sir, namaskar.
No.
Deepak, please stop recording.
One announcement is there.
Yes.
Dear participant, again will meet the last day at sharp by 9:45, and the session will be start sharp at 10. So be joined with the link by 9:45. Thank you. Have a good day.